What's up, AP Calculus? In this video, I'm just going to go over our next derivative rule, which is called the product rule. But before we get into that, let's just review the derivative of a sum. So if I want the derivative of f of x plus g of x with respect to x, I could just differentiate each function one at a time, and that will take me to the correct answer. That is also true for the difference of two functions. We'll get f prime of x minus g prime of x. And then people want to think that when we do the derivative of a product, it's simply just doing f prime of x times g prime of x. But unfortunately, that is not true. So make sure you write does not equal. That is a false statement. Okay, so I'm going to quickly show you why this is not a true statement. So imagine we had a function p of x defined by 5x squared times 2x cubed. Now we can rewrite this function by just multiplying the two terms together first. So that would give us 10x to the fifth. And now that we rewrote it, we could easily use our power rule to say what p prime of x is. So p prime of x would just be 50x to the fourth. We know that is correct. Now if we come over here and try to differentiate it before we rewrite it, using this as a guide, unfortunately, what that would look like is using our power rule, we'd have 10x times 6x squared. And when you multiply that together, we're going to get 60x to the third. Now we know that's not correct because it's actually 50x to the fourth. So let's make sure we write does not equal. This is the wrong way to go about finding the derivative of a product. So what you guys are going to see next is me just coming up with what's called the product rule for derivatives. So we want a formula that'll work for doing the derivative of a product. And to get it, I'm just running it through this limit definition of a derivative. So if I want the derivative of f of x times g of x, and maybe we should put with respect to x, that would be a little more correct. So you could add that in if you'd like. We're going to have f of x plus h times g of x plus h minus f of x times g of x over h. And going from here to here, I'll just quickly point out that I'm doing a little algebra trick where I'm putting this product and its opposite into the numerator because the sum of those yellow guys would be 0. So it's not a bad thing for me to do that. But the benefit of doing that, and I want you to try to follow my steps, is I could rewrite this fraction in this form. And then going from here to here, I'm using my limit laws. So when we get down to the end, to get our new derivative rule, we got the limit as h goes to 0 of g of x plus h. So just filling 0 in for h to do the limit, we'd be left with g of x times, now this limit represents f prime of x. All right, plus the limit as h goes to 0 of f of x. Well, since there's no h in this expression, that's just going to stay f of x. And then this limit would give us g prime of x. So do your best to try to understand what just happened there. But at the end of the day, this is what you want to memorize as the product rule for derivatives. This is correct. We're going to write this down here. So if I want the derivative of f of x times g of x, I'm going to keep the g of x the way it is, multiply it by f prime of x, and then add to that f of x the way it is times g prime of x. And that, my friends, is the product rule for derivatives. Okay, so for example 1 on the next page, we're going to work this problem out two ways, and you could decide which is better for you in the long run. But what I'm giving you is function f is defined as the product of these two binomials. So I just separated that with a multiplication dot just to make that abundantly clear. So if I want to use my product rule, all right, you can take this thing for a test drive. We could say f prime of x is me keeping the second factor the way it is, multiplying it by the derivative of the first factor. So if I use my power rule, this will go to 6x, and then the minus 2's derivative is 0. I'm going to add to that the first factor the way it is. We just leave it alone, multiplied by the derivative of the second factor. So that guy's derivative would just be 8. 5 goes to 0. So now we could distribute it and write it in another form if we'd like. So we'd get 48x squared plus 30x plus 24x squared minus 16. And if I combine my like terms, we're going to get 72x squared plus 30x minus 16. Okay, so that would be the derivative of the function I gave you using the product rule. Now, we have the option to multiply the binomials together first, then find the derivative. That shouldn't be a problem. So if I just keep this f of x equals 3x squared minus 2 times 8x plus 5, and then I FOIL that out, we're going to get 24x cubed, let's see, plus 15x squared minus 16x minus 10. And now that I rewrote it, I can then just get the derivative of each term one at a time. So using my power rule, 24 times 3 is 72, and we get x squared. 15 times 2 is 30, x to the first, minus 16x just becomes minus 16, and then minus 10's derivative is 0. So you can see you get the same answer using either method. So in that situation, you'd have some options. Now, if you go on to problem 2, we have this function defined as e to the t times cosine t. Now, unfortunately, there's no way to rewrite this, so we're kind of stuck. So here would be an example where we have to use the product rule. So why don't you pause the video, see if you could just apply the product rule to this and come up with an answer. Okay, welcome back, everybody. So using my product rule, I have my second factor times the derivative of my first factor. Remember, e to the t's derivative is just itself, plus my first factor times the derivative of my second factor. Derivative of cosine is negative sine. Now, when you put this together, just make sure you put the e to the t in front of the cosine. Don't unite it with this t here, since t is the only thing having the cosine applied to it. So it looked like that. Or sometimes in multiple choice questions, you might see the answer written in factored form. So you could always take the e to the t out and write it that way. Now, the next example, we have a function defined as g of x equals x squared times f of x. And we're not told what f of x is, but we are given some information about function f and the directions. So if they want to know the value of g prime of 3, and function g is defined this way, we probably should write down what g prime of x is first. Now here we really have no choice but to use the power rule. So we'll keep the second factor the way it is, multiply by the derivative of the first factor. Derivative of x squared is 2x, plus the first factor the way it is, times the derivative of the second factor. So now that we correctly applied the product rule, we can then use this function to calculate g prime of 3. So g prime of 3 would just be f of 3 times 2 times 3 plus 3 squared times f prime of 3. So why don't you pause the video, see if you can just take that one to the end, and we'll go over it in a second. Alrighty, welcome back. Hopefully you just filled in the values that you needed to fill in, and you get an answer of 69. Okay, the last thing I just want to mention is just the shorthand way to remember the product rule. So, you know, the way we wrote it on the front, nothing wrong with that, right? But if you want to condense that a little bit, we could kind of say, all right, if we want the derivative of f times g, it would just be what? The second function times the derivative of the first, plus the first function times the derivative of the second. Now, I don't know if this will happen on the AP test. I know there's some in our textbook, but you could always apply the product rule to the product of more than two functions. So let's say you have three functions being multiplied together. We could kind of write it like this, where you have to do the derivative of one of them while leaving the other two the way they are. So I'm just going to systematically write this out so I don't miss any. You could just take a look at what I wrote in a second. But essentially, we are doing the derivative of f, g, and h. And as we're doing that, we're just leaving the other two functions the way they are. So in general, that's kind of what the product rule is saying. And it's happening over here as well when I write it this way. All right, guys, that wraps it up for this video. So hopefully you fell in love with the product rule, and we'll be using it quite a bit throughout the year. Toodles.